Okay, folks, we are now ready to do a little review and talk about something new as well. So the last video that you watched had you working on systems of equations. And I want to give you some reminders here about what systems of equations are. When we talk about a system of equations, that is two equations on the same graph. So two equations on the same graph is what a system is. And I want you to remember that the solution to a system of equations is the point, or the points, because it could be more than one, where the lines intersect. Or touch, however you want to say that. So a system of equations is two equations on the same graph. And the solution, when they ask us to find that, is the point or the points where the lines intersect or touch. So the last time we did some work, you were doing problems like this. We could have y equals 1/2 x plus 9, and y equals negative x plus 6. So there's my two equations. And they're going to ask me to come up with the solution for that. So the way we did this is we came over here to our Desmos calculator and we typed both equations in. So we're going to do y equals, remember to get a fraction, hit your division sign first. And I'm going to put the 1 on top and the 2 on the bottom. Then don't forget to put yourself out beside the fraction so that the x winds up in the right place, and then my plus 9. So there's that first equation. All right, now I'm going to do y equals a negative x plus 6. And you'll notice it graphs the lines in two different colors, and I see my blue line and my red line intersect right there. So if I click on that point, that will give me my solution. So negative 2, positive 8 is the point where those two lines intersect one another. So easy enough. All we got to do is put the information into the calculator and then look at that graph and see where those two lines are crossing. Let's do this one. Let's do 3x minus 5y is equal to a negative 35, along with 2x plus y is equal to a negative 6. And we will again here identify the solution for this system. So I'm going to delete both of these. And then I'm going to type in that first one, 3x minus 5y equals a negative 35. So there's that. That's the green line. And then we're going to do 2x plus y equals a negative 6. It's done that one in purple. So again here I'm looking for where the green line and the purple line intersect, which is right there. It's at that one point. So my solution is a negative 5, positive 4. That point is the solution. All right, y equals x plus 5. X minus y equals 2. Find the solution. All right, so y equals x plus 5. So that line is graphed in black. And then x minus y equals 2. That one is graphed in red. Now notice what I have this time. I have parallel lines, lines that don't intersect. So if they don't intersect, then they can't have a solution. So notice, those first two examples we did had 1 point, an ordered pair that was the solution. Because these two lines are parallel to each other and don't touch, there is no solution for this system. And then I bet you remember there was one more kind. So we'll talk about that right here. Okay, so let's put in that first one, x plus 2y equals 4. So there's that blue line on our screen. Now let's do the second one, y equals, hit your division button first, -1 over 2, and click over here beside, so your x ends up beside the fraction, plus 2. And notice what happened there. You saw your blue line, and then when I typed in that last number, so let me back up for just a minute. See, there was that blue line. There's the first one. And the minute I hit that plus 2, notice the green line ends up right on top of him. So these two lines are really the same line. They end up in exactly the same spot on my graph. So on this one, remember, it is infinite solutions. And the reason it's infinite solutions is because those lines are touching everywhere. So that one would be infinite solutions. So that's what you did in yesterday's lesson. Now, what we're going to do for the next couple of days, or today and then on Thursday, is actually kind of build on that. Okay? So that's the old stuff. That's the old stuff. And you'll practice that a little bit more today with just a few problems. But then we are going to add on. So today, what we're going to add on are linear inequalities. This is not the first time we've seen inequalities. So here's what I want you to know about this. These are like our linear equations that we've been working on. These are like our linear equations, but they use less than, greater than, less than or equal to, and greater than or equal to instead of an equal sign. So these are going to be just like our linear equations, but they're going to use less than, greater than, less than or equal to, greater than or equal to, instead of that equal sign. So here's an example. 2x minus 3y is less than 15. Now see, we've been graphing things like 2x minus 3y equals 15. So let me show you that. Let's graph 2x minus 3y equals 15. So there's what we would have gotten. We would have gotten this nice, pretty straight line. This would be my y-intercept, because I'm crossing the y-axis at 0, -5, and then that would have been my x-intercept, 7.50. All right, now let's delete him, and let's look what happens if we graph him with that less than symbol. We get 2x minus 3y is less than 15. Now here's what I want you to notice. I want you to notice that the line ends up where it was before. You've still got an x-intercept, or a y-intercept, excuse me, of 0, -5, and you've still got an x-intercept of 7.50. But what I want you to notice is you've got now a line that is dotted. It's dashed. And that's happening because this symbol isn't underlined. So that's like that open circle that we talked about before. So because that symbol isn't underlined, this line is left open. It's left as a dashed line. And then you'll notice there's shading. Now, what you need to know is that the shading is the solution. So the shading for this thing is the solution. Now I'm going to see, can I change, no, that hides it. Can I change that color? Yes, I'm going to change that to orange, just so the next part of what I'm getting ready to do will make a little better sense to you. Okay, so here's what's going to happen. On today's assignment, they're going to give you these problems to graph, but then they're going to do this. They're going to say, tell whether each point is a solution. I want you to remember what I said. The shading is the solution. Okay? So, let's go through a few of these. That didn't work out too well. Okay, so my first point I'm going to ask you about is the point 2,5. Is the point 2,5 a solution? Now, here's how you're going to find out. You are going to go ahead and hit enter so you get a second box. Now you've already got your problem typed in, but now we're going to type in this ordered pair. So right here in my parentheses. So I am going to do parentheses, and then I'm going to type in this ordered pair. So I'm going to type in a 2, and you'll notice right over here is your comma, and then I'm going to type in my 5. And what you'll notice is over here on my graph, it shows me it's going to be a red dot, and over here on my graph, I see that red dot. So tell whether that point is a solution. Well, if it lands in the shaded part of the graph, then it's a solution. If it doesn't land in the shaded part of the graph, then it's not. So you'll notice that red dot is landing in that shaded part of the graph. So on this one, I'm going to say yes. That point is a solution because it lands in the shading. It lands in that shaded area. So the shaded area is where the solutions are. Let's try another point. Let's try -1, -7. All right, so what I would recommend you do is you delete this point. So let's get that second line again, and let's do parentheses. You'll have to put the parentheses. And then you'll put -1, comma, -7. Close your parentheses. Notice it said this time the dot would be this blue color. Here's that blue dot. Notice he is outside of that shaded area, outside of that orange shading. So on this one, I'm going to say no. He's not a solution to the problem. He's got to land in that orange shaded area in order to be a solution. All right, let's try 3, -4. So let's delete this point. Get your second line again and do parentheses, 3, comma, -4. Green dot this time, notice, not in that orange shaded area, so this would be a no. Let's do 0, 0. Let's see if he's a solution. So delete that one. Get that second line again and do parentheses, 0, comma, 0. Purple dot this time. Notice he is in that orange shaded area. So on this one we would answer yes. All right, I want to do one last point. Let's see if I can fit him in over here. I want to do 0, -5. 0, -5. So let's delete that point and do parentheses, 0, comma, -5. Now, here's what I want you to notice this time. It says the dot is going to be a black dot. There it is. And I want you to notice that it's landed on the line. Now, when the dot lands on the line, in order for it to be a solution, the line has to be solid. So when the dot lands on the line, in order for that dot to be a solution, the line has to be solid. So this one would be a no. This one would be a no because that line that I have landed on is a dashed line. That means it's left open. So in order for a point to be a solution on one of these, it has to land in the shaded area, or if it lands on the line has to be a solid line. So this is what you're going to be doing today, is you're going to be graphing these, and then you're going to be given a group of points, and you're going to have to say whether those are solutions or not. So this is going to be just a little yes or no exercise using your calculator. Okay, so we're going to do one more of these. Let's do y is greater than or equal to a negative 2/3 x plus 1. And then here are my points. We're going to do 0, 3. We're going to do negative 2, negative 1. We're going to do 4, 5. We're going to do 1, negative 1. And then we're going to do negative 3, 3. So we're going to answer yes or no whether those points are solutions. So I'm going to delete all of this time. And now let's type that problem in. So y is greater than or equal to. I need to hit my divided symbol to set up my fraction. And then I'm going to do negative 2 over 3 x plus 1. Now, this red shaded area is my solution, and I want you to notice this time the line is solid. And he's solid because this symbol was underlined. We've seen that before, but I wanted to remind you about it. So now what I'm going to do, now that I've got the graph in front of me, is see which of these points are solutions. And I'm just going to type them in to see. So parentheses, 0, 3. Purple dots, or a blue dot's what I'm looking for, and there he is. And you'll notice he is in that red shaded area. So this would be a yes. Okay, let's go ahead and enter. Let's go ahead and leave them up here. Let's do parentheses, negative 2, comma, negative 1. We're looking for the green dot this time, and here he is. He is not in that red shaded area. So he is a no. All right, next up, parentheses, 4, comma, 5. We're looking for the purple dot right here. He is in that red shaded area, so he is going to be a yes. All right, parentheses, negative 1, comma, negative 1. Looking for the black dot right there. He is not in that red shaded area, so he is a no. And then one last one to go. Parentheses, negative 3, comma, 3. We're looking for the red dot. Notice there he is right on the line. This time, since the line that I am on is solid, this would be a yes. So when you land on the line, if the line is solid, you are a yes. If the line is dotted, you are a no. So this is what you'll be doing, adding on today. You will be looking at linear inequalities, which are just like linear equations, except they have less than and greater than as their symbols. The shading is the solution. So if a point lands in the shaded area, it is a solution. If it lands outside of that shaded area, it is not. If it is on the line has to be solid for you to say yes. If the line is dotted, you say no, as far as is it a solution. All right, so that's today's lesson. Give the problems a try. It's all calculator, so it should be fairly simple. But if you do have questions, if there are things that don't make sense to you, email me. I'll be checking and I'll get back to you. All right, good luck today.